prove that 2n to the power of 3 minus 7n plus 1 is big omega of n to the power of 3. So why don't you pause this video and try on this problem, and then we'll go through the solution together. Are you ready? Okay, so we'll start with 2n to the power of 3 minus 7n plus 1, and I'll say that this is equal to itself first. Now, if I remove the plus 1 over here, of course this will no longer be an equal sign, but what will it be? Will it be greater than or equal to, or less than or equal to? Well, you guessed it, over here is greater than or equal to this expression over here. So what are we going to do next? Well, I'm going to show you a technique that I want you to know. Instead of writing 2n to the power of 3 minus 7n, we will write n to the power of 3 plus n to the power of 3 minus 7n. And it means the exact same thing. And I'm also going to put parentheses around the last part. Since n to the power of 3 plus n to the power of 3 minus 7n. Now actually I'm going to write an equal sign and write the exact same thing on the right side. So notice that this here is a polynomial to the third degree. It's n to the power of 3. And if you subtract n to the power of 3 with a linear function 7n, you're not subtracting much, right? You're really not subtracting much. So when you subtract, this will still be positive. This will be a positive function. Now with that in mind, if I remove this part over here, then what sign will we have? Is it greater than or equal to, or less than or equal to? Well, of course it's going to be greater than or equal to. So since n to the power of 3 plus this part is greater than or equal to n to the power of 3, we can rewrite our inequality up over here. So we have 2n to the power of 3 minus 7n plus 1, which is greater than or equal to n to the power of 3. And this is the same as having a coefficient 1 times n to the power of 3. This part makes sense because it's like saying A is greater than B, and B is greater than or equal to C, so A is greater than or equal to C. So you can see that's the case here. This function is greater than or equal to this, and then we write it down here, and we found that this is greater than or equal to n to the power of 3. So it makes sense that our original function is greater than or equal to n to the power of 3. We found our C. Let's find our n naught. So let's try substituting n is equal to 1 and see what happens. So we have 2 times 1 to the power of 3 minus 7 times 1 plus 1 greater than or equal to 1 times 1 to the power of 3, and see if this inequality is true. So here we have 2 minus 7 plus 1 is greater than or equal to 1. So we have negative 5 plus 1 is negative 4. Is this true? Well, the answer is no, right? So n naught cannot be equal to 1. We try again with n equal to 2. So we have 2 times 2 to the power of 3 minus 7 times 2 plus 1. We have 1 times 2 to the power of 3. So here we have 16 minus 14 plus 1. Over here we have 8. So this is 3 is greater than or equal to 8. Not true either. So we have to increase this to a 3 and see what happens. 2 times 3 to the power of 3 minus 7 times 3 plus 1. 1 times 3 to the power of 3. This will be 54 minus 21 plus 1. This is 27. We have 33 plus 1 gives us 34. And so this inequality here is true, and therefore n naught will be equal to 3. And the last step is to write the conclusion. So by definition, 2n to the power of 3 minus 7n plus 1 is big omega of n to the power of 3. Since our function is greater than or equal to 1 times n to the power of 3 for all n is greater than or equal to 3.